Hi kids, welcome back to Common Core Algebra 2. Today we're going to do 6.12, which is even and odd functions. So recall that functions are simply rules that convert inputs to outputs. These rules then can get placed into various categories such as linear functions, exponential functions, quadratics, and so on. All right, and they basically have shared characteristics and then different characteristics. So in this lesson, I'm going to learn another way to classify them that are based on useful symmetries. So we're going to have even and odd functions. Now, a function is known as even if f of negative x is equal to f of x for every value of x in the domain, and an odd function is f of negative x equals negative f of x for every value of x in the domain. So to put that in English terms, I like to kind of put things in English so I understand them. So basically, an even function, all right? So here we're going to talk about even functions. So right up here, I'm just going to write even functions, opposite inputs yield the same output. So that's kind of how you translate that one. And for our odd function over here, we're going to say opposite inputs yield different outputs. Instead of saying different one, it was the opposite. We kind of like that better. Opposite outputs. And we'll see what we're talking about in just a second. And I write that down. Whenever we're talking about even and odd, I write that down. And you need to carry this with you. This has to be put in that memory bank of yours. So exercise 1 says, consider the partial graph of the function f of x shown twice below. Sketch the other half of the function if a, f of x is even, and in b, f of x is odd. The three coordinate pairs are listed to help you plot them. So basically, if we come down here and we remember that in an even function, opposite inputs give us the same output. So obviously 0, 0 is still going to yield 0, 0. All right, opposite inputs, so that means negative 3 and negative 7 yield the same output, so it means I'm going to still get 5, and I'm still going to get negative 2 here. So let's plot those points. So we're going to be here, and we're going to be here. So if we did this properly, it should be looking something like that. Okay, so now we're going to move on to our odd function, where we have our same points here, 0, 0, and now it says opposite inputs yield opposite outputs. So that means negative 3 is going to yield a negative 5, and negative 7 is going to yield a positive 2. So let's take a look at what that looks like. Negative 3, 1, 2, 3, 1, 2, 3, 4, 5 is right here, and negative 7, positive 2 is going to be right here. So what's that going to look like? It's going to look something like 3, 1, 2, 3, 4, 5. I want to make sure that this looks right. Looks something like that. So it says in C, describe the symmetry of your even graph and the odd graph. Use use technically correct terminology as you can from your studies in geometry. So how would you describe, now remember this whole thing up here, over here, this whole thing here is really one graph. We just finished graphing it. All right, so in this case, how can we describe this? Well, there's a couple of ways we can, keeping our vocabulary academic from geometry. We can say even functions are symmetric across the y-axis. Another word you could use here is reflection. Okay, so you can say that the even function, so you can also say even functions are symmetric. We use the word symmetric, are are reflections over the x-axis, the y-axis. I know you knew what I meant. All right, so now let's consider odd functions. So odd functions, it might not be as obvious, but odd functions are symmetric about the origin. Okay? So finish writing down what you need to, and I'll meet you at exercise 3. So functions that we've discussed this year have been, some of them have been even, some have been odd, but most of them have been neither. All right, so let's consider the function f of x equals the absolute x minus 4. So evaluate this function for a variety of opposite inputs. So we're going to skip that part. We're just going to take that part out. We're going to go to B, and we're going to talk about how we're going to sketch this. So now, what's the easiest way to sketch anything or graph anything? Hopefully you're saying, well, with your calculator. So let's, we don't have a calculator. You don't have one at home. I have one here, but I don't think we need it. So let's consider our function, but we can consider just making a table of values, x, y, and see what happens here. Let's see what happens around 0. So -3, -1, -3, -2, -1, 0, 1, 2, 3. And if we need to adjust it, we can. So when x is -3, it becomes +3 minus 4, which is -1. This becomes +2 minus 4, which is -2. This is -3. This is -4, -3, -2, -1. So we can see that this also has a vertex, which is right here. So let's plot these points. 0, -4, 3, 4, and then we're here and here, and then we're here and here, and then we're here and here. And if I don't have it here, I would imagine the next one would then be here and here. And I'm going to do these because it makes my graphing a little bit more precise. So this is what this graph looks like. Always give it a label, y absolute x minus 4. Okay, so then it says, does it have the correct symmetry for your choice in A? Because A, we were supposed to guess what kind of symmetry it had. But we don't have to guess because we can just always throw it in a calculator and take a look at it. All right, so what type of symmetry is this? Hopefully it's pretty obvious to you because it's symmetric around that y-axis. This is an even function. So this is an even function because it reflects over the y-axis. So basically what that means is -3, -1 becomes 3, -1. So for opposite input, we have the same output. All right, I write that down every single time, and it might help you to write that. All right, so opposite inputs yield the same output. That's an even function. Okay, exercise 3 is at the bottom of this page, but I'm going to move to the next page and just write the function there. So the function that we're talking about from the page previously is this. That's the only thing that I'm missing. So it says use your calculator's table option to fill in the following table. So what type of function is this? So let's assume you have a calculator with you, and I will do the same. And actually, you don't even need it. You can do the math yourself. But I feel like that's trivial here. And this is what it looks like. So basically, quickly, I'm going to give this a shot at sketching. So I'm not going to waste your time by sketching it, so I'll come back in a second and we will make sure it is all sketched for you. So that's what our equation looks like. All right, so it is saying here, sketch the graph, use your calculator in the window below. So what type of function is this going to be? This is an odd function. All right, so let's write that down. So this is an odd function. And the reason I know that using our definition, I know that 315 goes to -3, -15, because opposite inputs yield opposite outputs. Okay? Write down what you need to, and quickly we'll do exercise 4. So basically here, if you take a look at this one, and you put this into your calculator and get your table, it looks like something like this. 0.125, 0.25, 0.5, 1, this is 2, 4, and 8. So you can see this is an exponential function if you remember what that looks like. It looks something like this. So this will be neither. Neither even nor odd, because we have -3.125 goes to +3, 8. So it does not fall into any of the categories for even or odd. Sorry about that. All right, so that's all we need to know about even and odd functions. So I'll see you in class, and we will continue working on our classwork. And until then, make good choices.